Good morning, everyone. Thank you for participating in today's new initiative, Market Parameters Enhancement, formerly known as Shift Factors Threshold. My name is Brenda Corona. I'm here with the Stakeholder Affairs Group. Today, I'm joined by Guillermo from Market Analysis and Forecasting. Today, our meeting, we will have a few meeting reminders to go over, as this meeting is going to be recorded and posted for informational convenience purposes only. Any related transcriptions should not be reprinted without the ISO's permission. Meeting is structured just to stimulate dialogue and engage diverse perspectives. So please feel free to ask any questions by using the raise hand icon on the top of your window, and we will call on you. After you're unmuted, please state your name and affiliation before making a comment. If you do experience any technical issues during the meeting, please feel free to send a chat to the event producer or myself so we can help mitigate the issue that you may have. But other than that, we will go ahead this quick agenda. As today, we want to make sure we go over review of the straw proposal, and that will be done by Guillermo. And lastly, the last step, we'll just go over the next steps about the commenting tool and the commenting deadline. And now I'll go ahead and introduce Guillermo. To feel free to unmute yourself and feel free to let us know. Guillermo, go ahead.
Thank you, Brenda. Good morning, everybody. Can you hear me okay?
Yes, we can hear you.
Okay, perfect. Thank you, Brenda, for the introduction. Let me give some background on this so that we can understand why we are dealing with this specific item at this point in time. You may recall that we have CRR policy enhancement that took place back in 2019. Based on that new policy, the settlements for congestion rates changed quite significantly. And right now, that logic relies on what we call a pro rata funding. Prior to this change, we used to have full funding, regardless of the deficiency. The deficiency was borne by the load-serving entities. After that change, we adjusted the CRR settlements such that we stay basically revenue neutral, and we are able to do the CRR payouts up to the amount of the congestion rents collected in the day-ahead market. Once we have that policy implemented, obviously we started to analyze the performance of that new functionality. And one of the market issues that we identified has to do with precisely the topic we are addressing today in this stakeholder call. And because of that, in the first few months after the implementation of this new policy, we start highlighting the inefficiency, the market issue that we identify in the congestion revenue rights settlement. And we intended to pursue a specific change to the what we call the shift factor threshold, and that was somewhere mid-2020. Then obviously conditions for the summer 2020 came, and we have to put this in a lower priority. Since then, I would say the logic hasn't changed, the issue hasn't been addressed, and that is the main reason we want to pursue this small enhancement to make the market outcome more efficient. Now, that was originally the intended scope of this initiative. Along the way, together with the discussions that we had for the summer 2020, we implemented some changes related to the load, exports, wheels priorities, scheduling priorities. And because of that, we also introduced some definitions of the penalty prices that we are now defining the tariff. Along that effort, we wanted to introduce a procedure for the CAISO to have the ability to make temporary changes because of the things can happen quite quickly. And because of that, we have some rejection from FERC, given the fact that it was outside the scope of the compliance filing that will happen in the summer 2021. We believe these two topics are naturally a good package to pursue for a more formal stakeholder initiative that eventually we want to bring it to the Board of Governors and file at FERC. These two items are somehow in the space of penalty prices, market parameters. They are not dependent. They are really independent one from the other, and we want to be clear that they are of such nature. But for efficiency in the process, we want to tackle the two together. And that is the reason that these two items, one, the change of the shift factor parameter threshold, and two, the procedure to expedite the changes to the market parameters, can be put together as one single initiative that is the subject of this stakeholder call. And we are going to tackle these two items through the initiative, and this is the scope of this specific effort. Next slide, please. Now, let me go straight into the first item. And this is a very interesting topic because it relates to markets. One that is the energy market, specifically in the day-ahead market, and more specific, the integrated forward market, that is the financial market in the day-ahead process, together with the congestion revenue rights market, the CRR market. And there is some dependency because obviously when we have to settle congestion revenue rights, they are based on the congestion rents that we collected from the day-ahead market. That creates that dependency, and there are some implications of the solution from the day-ahead market that may play a role into the settlements of CRRs. Now, this goes back to the basics of how the congestion management is done in the energy market. The congestion management is no more than the internal logic in the market clearing process to achieve optimal solutions that allow us to attain least cost solutions, but also to comply with the transmission constraints, thermal limits, security limits, and either lines, transformers, nomograms, interties, you name it. And the mechanism for the market to be able to effectuate that congestion management is driven by what we call the shift factor thresholds. These are sensitivity factors. And the shift factor is no more than a measurement that tells us how effective is one location, one injection at a certain location to effectuate congestion on a given constraint. And this is a very classical textbook definition that if you inject 1 megawatt in one given location and you want to withdraw that in the slack node, how much of that 1 megawatt injection is going to flow through the different constraints? If we have a shift factor, let's say, of 40%, that means that for every megawatt injected at that given location, 40% of that flow is going to be passing through a specific constraint. So the shift factor is the effectiveness measure relative between one specific location towards one specific constraint. When we derive that and shift factors, they are based on effectively the transmission configuration. There are inherent features, inherent attributes to the transmission system that help us to define those shift factors. Obviously, the impedances are one big component to determine what the value of the shift factor is going to be. The configuration, the connectivity of the transmission system is going to tell us effectively the shift factors. And these are effectively the two main components that define the shift factor value for a given location. In our market, we calculate all the shift factors for the applicable locations that we have in the system for any constraint that may be close or at the limit. And when we do that calculation, it's dynamically estimated based on the operating point. We have, as we described in the paper, we have some logic to determine the NA, the network application information, by running a power flow, a full AC power flow. We linearize around an operating point that allows us to calculate these shift factors together with the loss penalty factors, and that is information that is passed to the security constraint unit commitment, that is the market side, to find the optimal solution in terms of dispatches and prices. These shift factors are going to be inherent to the transmission configuration, and one of the concerns that came at the very early stage of implementation of the MRTU, the market nodal that we have back in 2009, was the concern that given very low values of some shift factors, there was a potential inefficient dispatch of certain resources to do congestion management. at that time, there were these scenarios in which you may have a constraint binding the southern part of the system, somewhere in SCE or San Diego. And you may have a, electrically speaking, far away injection, a generator that may be in the northern part of the system. And because the shift factor, the effectiveness to do congestion management on that far away, electrically speaking, location, we may have some inefficient way to do redispatch of resources. If you have, let's say, a resource of 200 megawatts, and that resource has a shift factor of, let's say, 1.5%, that means for every megawatt that you inject on that specific location of that generator is going to move from 1.5% of the power flow on a given constraint. So when you have these very small shift factors for specific resources, there is a need to have quite meaningful and large redispatches megawatt-wise to effectuate very little flow change on a given constraint. So in this case of 1.5, you would have to move effectively 100 megawatts to gain effectively 1.5 megawatts of redispatch on a given constraint. And this is going into the operational reality. It's not a good utility practice to have these very ineffective movements of redispatching resources to achieve very little gain in the congestion management. That is how the history came to have a threshold. And I was discussing with other ISOs, and it happens that we are not the only ones that have a threshold. And the threshold that we have for shift factors is 2%. Effectively, any location that has a shift factor that is smaller than 2% is not going to be considered for the congestion management. And congestion management is an abstract definition, right? But effectively, it means that you consider those locations, those injections at those locations to effectuate changes in the power flow of a given constraint. And obviously, that is going to have implications as well in the pricing of the congestion. It's always the dispatches and the price formation that has implications when we are dealing with the congestion management. And a second concern that happened in these early stages has to do also with the computational burden. If we start generating shift factors that are so small for every single resource, for every single constraint, when we have dozens, hundreds of constraints, and we have to do that basically for every single location, you start realizing the size of the problem. And because this is congestion management, it has to be present in order to do properly the congestion management. So it was a twofold objective, the ineffective redispatch that may happen with very low shift factors, but also keeping at hand the computational burden by the proliferation of too little shift factors. That is indeed the background that we have for how we came with a threshold of 2% to be applicable to shift factors in the CAISO energy markets. This threshold is applicable across the energy markets, in the day-ahead market, and also in the real-time market. Let's go to the next slide, please. What are the implications of having this threshold? Well, effectively, for every location that doesn't have a shift factor of at least 2%, is not going to be considered for the congestion management. That means it's not going to influence the dispatches or the prices related to congestion on a given constraint. And we apply that shift factor threshold across the board in terms of the different types of locations. And that includes the locations that are aggregated. And we have different types of aggregations, including aggregations for generation and load. For the load, the most typical aggregation we have is the default load aggregation points. That are the regional areas that represent the demand of a specific area, in this case, PG&E, SCE, San Diego, VA. And we also have some aggregated generation resources, such as trading hubs. These are the typical SP, MP, and VP26. And the threshold also applies to them. And here is where we start going into the complications that came visible once we start assessing the performance of congestion revenue rights. The original idea, the original concern about the ineffective movement was really mostly related to specific generators. When we translate that concept to disaggregated points, there is a feature that makes them quite unique in terms of the dynamic. It happens that the D-labs and trading hubs are quite large. When we are dealing with a summer typical day, we may have a load of, 45,000 megawatts. Easily, one of the D-labs, PG&E or SE, could be easily 15,000 megawatts of size altogether. When we are defining a threshold of 2%, 2% of 15,000 megawatts is effectively 300 megawatts, right? Let's say the case where we have a shift factor of 1.6 applicable to one D-lab, that is 15,000 megawatts in size. Well, 1.6% of 15,000 megawatts is 240 megawatts. Relative-wise, in terms of percentage, 2% seems to be small enough to be a good trade-off. When we apply that concept to these aggregated points, the labs and trading hubs that are quite significantly large, we are really talking about a significant absolute reference of 240 megawatts. Now, that on its own wouldn't be such a big problem. The complication is that it's relative to the size of the constraint we are dealing with. If we are dealing with a constraint that may be 3,000, 4,000 megawatts of flow, a contribution of 240 megawatts may be still relatively large, but it's not the most of what makes the constraint. But the historical challenge that we have seen in the performance of CRRs is that it has to do with constraints that are relatively smaller. We may have several constraints that may be a couple of 100 megawatts, 100 megawatts, 200 megawatts. And when we are disregarding the contribution of the D-labs or training hubs on that constraint, that contribution alone can be as big as the full capacity of the constraint. If you have a constraint of 100 megawatts, and now we are disregarding the contribution, the effect of the D-lab that could be, let's say, 240 megawatts, that is big enough to actually switch the direction. And we have seen this reversal of flows precisely because the lack of the contribution of the D-labs in the flow is big enough that it can result in changes that are bigger than the capacity of the constraint. That is really the inefficiency, the market issue that we have identified back in 2019. Specifically, it has to do with the interaction of D-labs and trading hubs because they are big enough relative to specifically and relatively small capacity constraints. And we did some extensive analysis of that back in 2019, 2020, and we also did something more recently. And the dynamic, the interaction between D-labs, shift factors, and size of constraints relatively small is still there. It's still an issue, and that is the main reason we want to pursue this enhancement. Next slide, please. How does this translate into the congestion revenue rights? So far, we have discussed only this in the context of the energy market. We have a contribution of the flow based on the shift factor, based on the injection of that location. When it is small enough, below the 2%, is not accounted for in the congestion management. Well, starting with the policy changes that we implemented in 2019 for CRRs, the whole calculation of the CRR settlements is based on shift factors. And in order to do this pro rata calculation, we have to assess the contributions of every CRR on every constraint individually. And that requires the calculation of the flow contributions by specific locations. And for that, you need the shift factors. And now when we are settling CRRs based on the day-ahead outcome, the shift factors that are coming from the day-ahead market are utilized to estimate that flow contribution. There are two levels of complications here, and it could be in either way. The first one is that the lack of accounting for the DLAPs and trading hubs contributions on the flows can result in an overpayment of CRRs. When we clear CRRs in the CRR markets, allocations or auctions, and we don't have a shift factor threshold. Every single shift factor is considered, but we do have one for the energy market. So you can easily see that when we have to settle the CRRs that were cleared based on the CRR model, based on all the shift factors, and now you apply that to a specific shift factor from the day-ahead market, the shift factor from the day-ahead market is going to be a subset, ignoring basically anything that is below the 2%. Rather, you may end up with a delta, with a difference. And that difference can be underpayment, overpayment. In this case, we specifically pointed overpayment because that is the instances that we were able to assess. It doesn't mean that it's the only direction. There may be other cases in which this may result in underpayment because all what matters is the contribution of the flow, and that contribution can be in the prevailing direction or in the counterflow direction, depending on the specific conditions of the constraint and the location. Again, the historical events that we analyzed were specifically pointing to the case of overpayment, but in concept, it could also happen for underpayment. And the second complication is that by this logic of the shift factor threshold in the energy market, we may result in an undercollection of congestion rates, and precisely because we are cutting off any contribution below the 2%. We have provided quite an extensive analysis as early as 2020, indicating what was the issue with this shift factor threshold and how it was related to the cutoff applicable to the labs and trading hubs. In the first month that we assessed that impact, the value was about $3 million, and that was for a specific set of months back in 2020. We have done a subsequent analysis in Q1 2022, specific to one constraint in the northern part of the system, is the Moraga constraint, and we can see effectively the same logic, the same interplay, in which the lack of accounting for the contributions of the labs and trading hubs that are meaningful enough relative to the size of the constraint, because the constraint is relatively small, is creating this unintended consequence that you could end up collecting less congestion rents than what you actually have to have. And in some cases, because of the magnitude of the changes, it could be large enough to reverse the direction of the payment. That means a CRR holder having a contribution of flow on that specific constraint may end up being charged for having that CRR just because we're ignoring the counterflow position of the labs and trading hubs. Next slide, please. So this is the background, the issue at hand, and what we want to discuss through this initiative is what options we have to address this issue. The 2% threshold is in place for a reason, and we believe that is still the case because still ineffective movement of the dispatches can still happen when you have this shift factor below the 2%. Now, the competing item here is that when we apply this to the D-labs and trading hubs, we end up with this unintended consequence of the lack of accounting of these flows to be too large to be disregarded. The trade-off that we are proposing here is that we can keep the shift factor threshold effectively for all the locations as we currently have, with the exception that we do not want to apply that threshold to the labs and trading hubs. Effectively, we would have two thresholds. One is 2% for any individual location or even some small aggregated locations, but specifically for the labs and trading hubs, we will no longer apply the threshold. Now, I have to caveat this a little bit. We're still doing some simulation analysis. In concept, the idea would be to not apply the shift factor threshold. Effectively, the shift factor as small as possible would still be considered. We have to ensure that this remains practical, and we still have to figure out whether, strictly speaking, zero threshold is good enough to have in the system, or may have to be relatively non-zero threshold, a very tiny, small amount to make it non-zero, but practically to have the same effect of a zero threshold or no threshold at all. That is something that we have to determine, and we will have that ready by the last round before we complete this initiative. But the concept is there. Effectively, we don't want to apply the threshold of 2% to the DLAP. So it's going to be such a small near to zero value that in practical terms is not going to have a threshold. Any other location will continue to be as it is today with a 2% threshold in place. And that will be across the market, right? Because we want to keep the consistency. The shift factor threshold has direct implications on price formation and also dispatches. And we want to ensure that signal, that price formation, and that the dispatch logic is consistently applied across the market. This is the proposal. Is, I would say, quite straight. And I would like to pause, Brenda, to see if we have any questions at this point.
I do see actually one question in queue. Callie, your line is unmuted. You may go ahead.
Hi, Guillermo. It's Callie Wells with WPTF. First of all, thank you so much for not losing sight of this issue. And we know the last couple of years with summer enhancements has been busy. So first of all, thank you guys for bringing this back up. I had a couple questions. First, I think at the beginning of the presentation, you mentioned that other ISOs apply a similar threshold. I was just curious if you can elaborate on that a little bit more, if I heard you correctly. Is it in the same relative magnitude as the 2%, and do they also apply it to some aggregated locations and not others?
Yeah. Well, I was in a discussion with other ISOs, and this specific topic came live to that discussion. I don't have specific details of every ISO, but I will make sure to put that level of details in the next round.
Okay, I appreciate that. And my second question, you just mentioned the impact on price formation. And I know in your paper you spoke to kind of this will have an impact on the marginal congestion components. Can you elaborate a little bit more on what you expect? I guess I'm most interested in what you would anticipate happening to the congestion component at these the DLAPs compared to what we see today.
Yeah, and that's going to be very tricky, Kelly, because it could play in either direction, depending how that DLAP, how that trading hub is impacting the flow on a given constraint. And there are only two options, right? An injection at a given location can either mitigate or exacerbate congestion, and that's it, right? Or, strictly speaking, no impact. That would be a shift factor of 0. That is typically unlikely, but there could be cases where there is no, the shift factor is 0. In that case, there is no impact on that constraint, so it's going to remain the same. Now, for any other location, it's very relative because it depends on the specific constraint and where that location is relative to that constraint. If a DLAP or trading hub is historically and will continue to mitigate congestion, that means it's going to provide counterflow to the flow on the constraint. Effectively, it's going to be a positive congestion component, right? It's signaling that we need to increase generation on that location or demand in that location so that we can mitigate for the congestion. Conversely, if that trading hub or the lab is going to exacerbate congestion, the marginal congestion component is going to be negative and it's like penalizing that location because it's exacerbating the congestion. That is just the basic principle of price formation related to congestion management. That continues to play its role as it is. The difference here is that now the DLAPs and the trading hubs are going to have a contribution to that interplay, because before it was truncated, if they were below the threshold, they didn't account for nothing. Effectively, there was zero contribution. Now it will be a non-zero contribution, potentially small, but it's going to be a non-zero contribution. Whether it's going to increase or decrease the congestion on that location, on that DLAP or trading hub, is very relative, and it depends on whether they are in the prevailing or counterflow direction. So it's going to be very constraint specific. The material change is going to be that there will be now an explicit contribution of that DLAP and trading hub to the dispatch to manage congestion on that constraint, and therefore there will be a small component now coming from the DLAPs and trading hubs to the MCC, to the marginal congestion component. But again, the direction is relative. It depends on the combination of the DLAP trading hub relative to the constraint.
Okay, yeah, no, that makes sense. And my follow-up question is, so I understand your justification for kind of narrowing in on the DLAPs and the trading hubs. Is there a plan to continue to monitor whether or not any other aggregated locations like custom laps might need this threshold removed at some point in time?
Yeah, and we analyzed that when we were coming with this approach, and I can tell you that the DLAPs and trading hubs were the only ones that are completely out of range, right? Because we're talking about thousands of megawatts. Even some small custom labs or sub-labs, even though they may be by definition aggregated locations, sometimes they are not even bigger than a specific individual generating resources. So they are not per definition, but it's more by the magnitude of their injections that is really the threshold line here to define which resources we should account for. And at this point, we don't envision to go beyond the DLAPs and trading hubs, just because they are the ones that are magnitude-wise quite out of range relative to any other location.
Okay, I appreciate that response. Thanks, Guillermo.
Thanks, Kelly.
All right, there are no additional questions in queue at this time.
Okay, let's move on to the second topic. And this is more of an administrative procedure, but it's quite critical to have this discussion because we find the value to have this in place. And this is somehow related to the first topic by the nature of the area of the market we are discussing. As you know, we have a centralized least cost market, and we rely on bids to clear supply and demand. When we are able to utilize all the bids that are available, either economical bids or self-scales, I would say there are effectively two zones of operation of the market. The ideal happy path of operating the market is when the market has enough economical bids to clear supply and demand and do congestion management. There is a price responsive bid that allows the market to find the optimal solution. And therefore, when the least cost solution is attained, there will be some marginality defined by these economical bids. When the market starts to get stressed by a variety of conditions. We have limited resources to do congestion management. We have limited and tight supply conditions. We have too high demand. You name it. Once we start reaching these stress conditions, the market may start operating in a different region of marginality. And that region is where there are no longer enough economical variables to achieve a market solution. That is when the market has to rely on the next step of the dispatch. And these are the variables that the market has to account based on what we call uneconomical adjustment. For instance, ideally, we want to be able to have enough resources to do congestion management. However, when we run out of redispatch movement for a specific constraint, the next step is to relax the constraint, to violate the limitation of that specific constraint. That is what we call an uneconomical adjustment or a constraint relaxation. When we have, for instance, oversupply conditions, and we have just too much generation in the system, there are no more decremental bids. The next step for the market is to start reducing the self-schedules. These are uneconomical adjustments because they are not price-sensitive bids. They are these quantities that are basically price takers and are willing to take any price. When we have to rely on that region of uneconomical adjustments and constraint relaxation, the market needs to still some sequencing, some priority to define what to cut, what to violate, or what to relax first. And that is when this set of parameters come in place. We have a variety, a long list of different penalty prices. Penalties just because refer to the nature of how expensive it is to violate or to adjust that schedule. And these are set of parameters that are sitting in the market. Each market has a specific set of market parameters relative to the conditions that we're dealing with in each market. And we have parameters related to transmission constraints, to other type of system constraints, but also to scheduling priorities. When we have to define those parameters, it's typically when we have to come with a new market functionality, a new product, we do this holistic assessment of what the right calibration and synchronization of these parameters should be. We do that one time before going live with a new feature, and we continuously assess the synchronization and the calibration of these constraints. It is not feasible to have a set of parameters assessed based on every potential permutation that you can find in the system. And that is one of the complications. We have to do the calibration and determination of these parameters based on the typical scenarios. We run some stress scenarios to ensure that under these stress conditions, these parameters are able to still give us a proper solution. However, there will be from time to time very outlier scenarios in which the standard definition of the parameters may break because there was some interplay, some combinations of factors that simply lead to an unintended or inefficient market solution. When that happens, we obviously assess what should be the right calibration of the parameters. And quite frequently, that may require that we adjust a few parameters to be able to handle that specific scenario, in addition to the standard conditions that are happening day to day. Prior to the policy changes that we implemented in 2021 for the scheduling priorities, the majority of the penalty prices that effectuate in the market were defined only in the business practice manual. There were very few, like the one that we just discussed for the shift factor threshold, that are hard defined in the tariff. Therefore, when it was a matter of changing a parameter that was defined in the BPM, it would be a process of initiating a business practice manual change, and we could effectuate the change. Now that we have this defined in the tariff, obviously we cannot do it in an expeditious basis because it requires a process to be able to effectuate a change in the tariff. When we were filing the scheduling priorities back in 2021, we realized of this complication, and we still need, in practical terms, to have a solution, a process that allows us to mitigate as soon as possible once we find these unintended or inefficient outcomes. And there have been a few cases in the past that highlight this need. For instance, some of you may be familiar with the overscheduling of interties stakeholder process that we just completed back in January. That was an issue that we identified basically by the time it happened. That afternoon when we were running July 9, we saw that inefficiency in the outcome coming out. But we couldn't do much because it's a value that was defined or is defined in the tariff. Therefore, even though we could see the inefficiency, operators have to rely on manual curtailments to try to mitigate for that inefficiency. it was not optimal that we couldn't effectuate the change directly in the market, and obviously that poses some unintended and inefficient market solutions that could land into a reliability concern unless the operators take effective action. Next slide, please. That is the reason that by the time we were filing these scaling priorities, we wanted to have this procedure in place. The idea is that we could identify the issues and we could change specific parameters quick enough to stop the unintended or inefficient market solutions. We learned that other ISOs may have similar provisions for some parameters in the market, and we were looking for something similar. Now, when we filed that as part of a compliance assessment, there was some concerns from the stakeholders that this idea of having a process to implement expeditious changes through an internal process could be too far in the scope that would allow the CAISO to effectively change the relative scheduling priorities. In a subsequent filing, the CAISO clearly indicated that that was not the intent, that the scope was limited in terms of changing the specific values of the parameters that wouldn't imply to change any relative scheduling priorities. And that is still the intent, and we made that case clear in the supplemental filings back in the summer of 2021. Next slide, please. FERC rejected that proposal, not on the merits of the proposal, but was more on the administrative procedure that we were following, because we were putting this as part of a compliance filing. So they indicated that CAISO could pursue to submit a tariff amendment, and that is exactly the reason why we are here today in this stakeholder initiative. We want to proceed with that original proposal that we have back in the summer 2020 and do this through a tariff amendment. The merits of the process is still the same. The idea is that once we are able to identify an unintended or inefficient market solution that could pose a reliability condition, that the CAISO could temporarily change the penalty price or the parameter values quick enough to stop that inefficiency and keep that change up to 90 days. With the 90 days, we would have the opportunity to then prospectively file a change within the first 30 days of the modification. We consult that with the Department of Market Monitoring. We would inform FERC about this. The idea is that we could have the agility to be able to stop an inefficient outcome to continue to happen. And I go back to the original case I described, for instance, of what happened in July 9. We saw the inefficiency of the market over scheduling imports on the intertie of Malin and NOP when we have these rates due to the fire impacts. And that was a solution from the market. Effectively, it was allowing imports to clear in excess of the capacity of the intertie. And the consequence was that we could not that allow to happen. Therefore, the operators have to manually curtail after the fact the schedules on those interties, and we couldn't effectuate the change simply because it's defining the tariff, and that required a whole process to make the change. Right now, effectively, we are waiting for that resolution from FERC, but that just highlights that in order to go through the normal course of action to make a change, it may take some months after the event happened, right? If this is an ongoing issue, it would be quite expensive to allow that inefficiency to continue to happen for so long. And this is what we are looking for, a procedure that allows us to make more expeditious changes when the need arises. That's really the scope, the issue, and the proposal that we have for this specific second item. I think this is a good time to have any follow-ups or questions, Michelle.
All right. I do not see any questions in queue at this time. As a reminder, ladies and gentlemen, pressing the raise hand icon above the chat panel will put you into the question queue. And if you are joined via telephone for audio, please press #2 on your telephone keypad to enter the question queue. All right. I do not see anybody in the question queue.
Okay, can we ask if there are any questions for any of the two topics before we move to the end?
All right, I do not see any questions in queue, Guillermo.
Okay, well, that's all what we have for today. We're trying to make this an expedited process. The issues very clearly identified. We have a very targeted and proposed solution. We would like to do it as fast as possible, obviously, to make the market enhance as soon as possible, but also to avoid any complications with the time schedule. We have the next step that is to be submitting comments, and we appreciate any feedback that you can give us by written comments, and the due date is next week, May 9. And we are expecting that right after that we can have the final proposal before we can come to the Board of Governors. If you have any questions, please don't hesitate to reach us, and we would be happy to address any questions so that you can have an opportunity to submit any comments. That's all what I have for today, Michelle, Brenda.
Thank you, Guillermo. I think we have everything today. Reminder, comments are due by the end of day, May 9th. Let us know if you have any questions. Also, the last slide we have presented is just the stakeholders save the date coming up in November 9th and 10th. But other than that, we can go ahead and pass it back to Michelle to conclude this meeting. Thank you.
That concludes our conference. Thank you for using Event Services. You may now disconnect.